Hello everyone. In this video, we're going to learn about the different types of network topologies. So, as you can see the definition, a topology refers to a physical or the logical arrangement of the devices. You have n devices and how you are going to arrange it as per your requirement, your laboratory or your research area. So, how you are going to arrange it. So, that is called as a topology. So, I have listed the different types of topologies. We have point to point, mesh, star, bus, ring, and the hybrid topology. Let's look at the explanation of each of them. So first, point-to-point connection. As the name says, there is a direct connection and it refers to two values or two devices. So at the end of one cable, there is one endpoint and the other end is another endpoint. That's it, very simple. And then coming to fully connected mesh topology. A mesh topology refers to having every node connected to every other node in the network so that there are dedicated links for connection. So if one PC, as you can see in the diagram, one PC has a cable to connect to all the other four PCs. So that is the advantage. So you have dedicated links and the communication is perfect all the time. So that's why it ensures robustness and you have a private communication channel for every device. So that is also an advantage and easy to identify the fault. If suppose one PC is not able to communicate to next PC, then only that cable we have to make sure whether it is doing the transmission or not. These are the advantages. But there are some disadvantages as well. The first disadvantage is the number of cables increased. The requirement of the cables is increased, and then too much of IO ports is required at every endpoint, and then difficult to move. So you can't move the structure due to this too much of cabling. You can't move the structure easily. Then moving on to the star topology. As the name says, star, there's like a central hub will be there, a central device, and to which all the end devices will be connected to. So that whenever a device wants to communicate to another PC, suppose a PC A wants to communicate to another PC C, how it will do? It will send the packet through the hub only. Okay, so that is the problem over here, and there's some difference between the hub and the switch they mentioned over here. So the hub is going to do the packet transmission to all whoever connected to it, whereas the switch, it identifies and forwards appropriately. So that is the star topology. So what is the advantage of star topology? Since every device is connected to the central hub, so the number of intermediary devices is reduced, and then one input output port is only required because one PC is going to get connected to only one hub. So the number of IO ports, number of cables are required is less, and easy to install, robustness, easy to identify the fault. If suppose one PC is failed, then it is easily identified. And the drawback is if the central hub fails, that's called as a single point of failure, then the whole network will be isolated. And then more cabling is also required because every PC is connected to the hub. That is the disadvantages. And then moving on to the bus topology. This is like a creating or arranging your devices in a linear fashion. So here you can see there's a drop line that gets connected to some common line that gives you the bus kind of structure. So there is a terminator at the end. So what is the advantage and disadvantage of this kind of structure? So little cabling is required. Okay, that is a point, and easy to install. That is the advantage. And the disadvantage is when you have to modify it, then it becomes a drawback. And how many number of devices you can connect it to this central cabling? That's also a problem. And then difficult to isolate the fault since it's all been connected in a linear fashion. You can't identify the fault very easily. So it break in the bus cable stops all the transmission. So this is also going to uh, stop the packet transmission throughout, and that is a drawback. And then moving on to the ring topology. So as the name says, ring. Okay, the devices are connected in a circular fashion. So the packet moves in one direction and then reaches the other. Suppose if A wants to send a packet to D, it has to move to B, C, and then reaches the D. So the advantage of ring topology, it is easy to install, and also we can identify the fault very easily. But what is the disadvantage? There is a delay in the large ring. As I mentioned already, if A has to send it to D, then it has to cross the intermediate nodes B and C. That creates unnecessary delay. So, and then the break in the ring stops all the transmission. That is also another serious issue in the ring topology. Moving on to the final one, which is a hybrid topology. So, there in a very larger network, obviously it's going to be a hybrid topology wherein you create multiple structures for your overall end devices. So now comes a comparison chart of all the different topologies. So as per this table, you can see the failure, the one which is very difficult to solve is the ring topology. And then the one which is very cost is everything, ring, star, and particularly the mesh topology requires very high cabling, because there only every node connects to every other node in the network. So, and the traffic is very high in case of ring topology, and the efficiency is more in all the topologies except the ring topology. And then the network performance is in case of ring topology, it can be a small or large, otherwise it's all small. What about the cable length requirement? So it is more in case of the star and the mesh topology. Okay. These are some of the comparisons of various network topologies that we have learnt now. Thank you.